is a big threat to human health, although there are many therapies. But do you know that even after surgeries, patients can still at risk of cancer metastasis? How do we decrease this risk? Welcome to CDC Fast. Nearly 10 million people die from cancer annually worldwide, accounting for 1/6 of total global death. Among these patients who died of cancer, the most common were lung cancer patients, for 1.8 million fatalities, which is twice as many as the second leading cause. Consistent with the global trend, cancer is the leading cause of death in Taiwan, and with the lung cancer the most common. According to statistics, most of the deaths caused by lung cancer are due to cancer metastasis and cannot be treated. So, what is metastasis? Metastasis refers to cancer cells breaking away from their original site, entering the bloodstream and lymphatic system, and forming a new tumor in other organs. The cell is called circulating tumor cell. Such metastasis can impair the function of other organs and lead to systemic issues which results in death. The metastasis detection techniques currently include computed tomography scans, magnetic resonance imaging scans, and circulating tumor cell detection. The detection techniques currently include the CT scans have high radiation concerns. If used too often, it may cause cell damage. MRI requires a strong magnetic field and is rarely applied to more complex diseases. The CTC detection is an antibody-based assay, making it the least risky option for screening. However, the CTC detection still has its drawbacks. The delivery and storage of CTC detection keys need low temperature, and the detection device is unaffordable for ordinary hospital. This all makes CTC detection inaccessible and inconvenient for post-operative follow-up patients. To overcome the drawbacks of conventional CTC detection, we developed the automatic CTC Fast device. CTC Fast is a user-friendly device capable of automatically labeling and detecting CTCs. First, the device is divided into the capture and label system and the fluorescence detection system. The raw material in capture and label system is folic acid conjugated DNA tetrahedron, and the green fluorescent protein detected by the fluorescent detection system, which is freeze-dried and allowing the room temperature storage. Through the CTC Fast device, the CTC detection becomes a more affordable and accessible choice for post-operative follow-up patients, consequently decreasing the death caused by lung cancer. So, how does the CTC Fast device work? First of all, 7.5 milliliter of blood is drawn from patients by medical staff. After density gradient centrifugation, the peripheral blood mononuclear cell containing a circulating tumor cell is retrieved as a test sample. With injection, the test sample is introduced into the main chamber of CTC Fast device.
So, in order to capture CTCs, it was known that the folate receptor is enriched on the membrane of lung cancer CTCs. Therefore, we utilize the high affinity of folic acid and folate receptor to capture CTCs. To immobilize the folic acid on the wall of the main chamber, we apply DNA tetrahedron as adapters. DNA tetrahedron is a DNA nanostructure formed by single-stranded DNA, ssDNA for short, in a complementary manner. The single-stranded DNA overhang at one endpoint of DNA tetrahedron function as a switch to complement folic acid conjugated single-stranded DNA. This design allows the feasibility for exchanging folic acid with other aptamers in the future. The docking of DNA tetrahedron on the wall of the main chamber is mediated between the zinc finger protein and the corresponding binding motif at the edge of DNA tetrahedron. Typically, 4 separated single-stranded DNA can form a DNA tetrahedron. However, the side product formed by the uncontrolled complementation is easily observed in the gel electrophoresis. To avoid the uncontrolled complementation, we designed a long tetrahedral single-stranded DNA which can self-assemble into a DNA tetrahedron. Unfortunately, the highly complementary sequence limited its production by manufacture. To overcome this unexpected problem, we applied the in vivo rolling circle replication and the auto-splicing mechanism to generation tetrahedral single-stranded DNA in bacteria. In rolling circle replication, the Rep-A protein recognized the RCOR1 105 start point and RCOR1 65 start point and transcribed the intervening sequence into the circular single-stranded DNA. The circular single-stranded DNA is protected and bound by the single-stranded DNA binding protein, which is also applied for single-stranded DNA purification. After purification, the zinc ions is aided to trigger the splicing of auto-splicing motifs in the circular single-stranded DNA, which to generate tetrahedral single-stranded DNA for assembly. Finally, the folic acid conjugated single-stranded DNA complement to the overhang of DNA tetrahedron is assembled together for CTC capture. To label the captured CTCs, we produce the fusion protein of green fluorescent protein and a peptide, which specifically recognized the folate receptor alpha on the CTC membranes. This fusion protein could be freeze-dried without losing its function. With this design, we could capture and label CTCs and store all reagents at room temperature. To release the labeled CTCs, we further inserted the trans-auto-splicing sequence into the folic acid conjugated single-stranded DNA. The addition of single-stranded DNA recognizing the trans-auto-splicing sequence and the zinc ions will release the CTCs, allowing the CTCs to enter the fluorescent detection area for counting their numbers.
To align the released CTCs for the fluorescent detection system, we built up Trident microchannel, which contain amine channels with diameters of 150 micron and 2 branch channels with diameters of 300 micron. The branch channel utilized sheath fluid to confirm the CTC's movement in the main channel, allowing CTCs to pass through the 488 nanometer laser beam one by one. And the ambient lantern labeled CTC are excited by the 488 nanometer laser beam. And the emitting fluorescence can be detected and counted by the photodetector, with the results displayed on the screen. After interviewing with experts and medical laboratories, we suggest that more than 5 CTCs in 7.5 millimeters of blood is a sign of metastasis, and further medical examinations is recommended.
Besides the CTC fast device, we thought to find out what else we can do to decrease the death caused by lung cancer. The World Health Organization indicates that early detection, healthy life, and the awareness of cancer-related symptoms and severities all benefit the cancer prevention. Through the street interview, we found that approximately 80% of the public is unaware of the severity or symptoms of lung cancer, not to mention the CTC detection. Therefore, Our education goal is to raise the awareness of lung cancer severity and symptoms in the public. Meanwhile, to emphasize the importance of synthetic biology in improving CTC detection. To this end, we held an open lab event to inviting the local high school students to operate the synthetic biology experiment and sharing some knowledge of lung cancer prevention, as well as to emphasize the synthetic biology. We started the idea from medicine and food comes from same source, which is highly recommended in traditional Chinese medicine. We collaborated with the school cafeteria and launched a healthy bento for a healthy life to reach undergraduates in our college and to share the ingredients good for lung care. On World Lung Cancer Day, we held seminars in our town to share the communities about the risk factors of lung cancer and provided some methods and strategies to reduce this risk. Also, we provided some information about lung cancer prevention on our social media platforms. One of our posts reposted on the International Lung Cancer Awareness account. We initiated the postcard campaign where individuals write encouraging and supportive messages about lung cancer prevention. These postcards are sent to friends both domestically and internationally, as well as to Argentines. This postcard was served as a warm keepsake and symbolized our collective concern for health. We believe that through these efforts, CTC Fest can not only promote the widespread adoption of CTC detection, but also raise the public awareness of lung cancer, ultimately reducing the death number of patients who succumb to death. We are CTC Fest. We are going to change the century fast. It's the end of our presentation. Thank you for listening. Feel free to ask the questions at our team booth. Is at Q3 and Group B. Thank you.